Okay, this is a flipped class lesson, so you need to watch this video on your own time. It will not be gone over in class. Instead, during class time, you will be practicing what you learned here in the next few minutes. So, we're on our new unit. It's called Polynomials, but before we can start really getting into the unit, we need to go over some definitions and like things. So, the first thing we need to say is, what is a polynomial? A polynomial is the sum or difference of numbers and or variables with natural numbers as the exponent. Natural numbers as the exponent is going to be key, so remember that. Natural numbers. Natural numbers are also what we call counting numbers. So natural numbers only include numbers 1, 2, 3, 4, it goes off into infinity. This means no decimals. This means no negatives. This also means no fractions. So, some examples of what polynomials are on the left-hand side. So these are examples. All of these are different types of polynomials. You'll notice they're polynomials because the exponents you see are all natural. For instance, this is an exponent of 2, this is an exponent of 1, and there is no exponent over here with that other number. So that means this is a polynomial. On the right-hand side, you'll see examples of non-polynomials where there's exponents that are negative, there's exponents that are fractions, there's square roots. Remember, square roots are the same thing as fractional exponents. And you notice there's one more here where you have x squared. And you might be thinking to yourself, that's a natural number, but it's not a polynomial because there's a variable on the bottom. So no variables on the bottom is also necessary. Because there's a letter on the bottom, doesn't count. Alright, so fill in the blank. So a number without a variable is called a constant. An example of that is if you had a polynomial such as 4x squared plus 2x plus 3. Notice that the number 3 doesn't have a letter right next to it. There's no letter right here, so we call this number the constant because there's no letter attached to it, no variable attached to it. Second one, polynomials are in simplest form when like terms are combined and they are written in ascending order. You could also say when they're written in alphabetical order because that's also important. Sorry, this is ascending. I meant descending. So if you just wrote that in your notes and now you have to erase it, I'm sorry. Descending order. And when we're talking about descending order, we're looking at the exponents. So, for instance, 4x squared plus 2x plus 3. Same polynomial we looked at before. That's written in simplest form because it's in descending order when you look at the variable or the variable's exponents. So 2 is the highest exponent we see, 1 is the next exponent, and then no exponent, no letter goes last. So you always want to go highest exponent first and work your way down. You also want to make sure you go in alphabetical order if there's more than one letter. Okay, last one. The leading coefficient. Leading coefficient. The leading coefficient is the number in front of the variable with the largest degree. Largest degree means highest exponent. So for instance, if we looked at 4x squared plus 2x plus 3, the number 4 would be the leading coefficient. 4 would be the leading coefficient because it's next to the letter with the highest exponent. We call that the largest degree. So largest degree and highest exponent mean the same thing. All right, a few more definitions we need to get through. So first off, we have different special types of polynomials. For instance, if there's only one term, we call that polynomial a monomial. So monomial means one term. So for instance, x would be a monomial, or 4x, or 3, or q. Those are all monomials because there's only one term. Binomials. Binomials are things that have two terms. So for instance, x minus 2. That's two separate terms because they're separated with a plus or a minus sign. Another one would be 4 plus y. Or x squared minus 2. These are all binomials. The last special one we have is called a trinomial. Trinomial is when there's three terms. So for instance, x squared plus 2x plus 3 would be a trinomial because there's three terms. They're separated by plus or minus signs. And they all have different degrees. So they all have different exponents. Lastly, a polynomial. A polynomial is just for anything that's more than three terms. So x to the power of 4 plus x squared plus 2x plus 6. That's more than three terms, so therefore we just call it a polynomial. And that could go up forever, so you could have a 100-term polynomial if you wanted. Okay, now that we've kind of got our definitions down, we're going to do some things and practice some things with polynomials. The first thing we're going to practice is called algebra tiles. You guys might have seen these before. We represent algebra tiles three different ways. So the very big boxes, are called x squares. The little skinny sticks are called x's, and the individual little guys represent single numbers. If you have a shaded in box, that means it's a positive value. And if you have a non-shaded in box, you mean it's a negative value. So our question here is, represent the polynomial 2x squared minus 3x plus 1. So first when we look at this, we see 2x squared. That means we have 2 x squared blocks. So we have two big shaded boxes. Next, it says we have minus 3x. So that means we need to grab our negative tiles. Negative, and there's negative 3 of them. Lastly, there's a plus 1. Oh, I moved the 1 instead of the little box. There we go. Plus 1. So this represents 2x squared minus 3x plus 1. All right, so we're going to practice one more time. We're going to represent the addition of the following polynomials using algebra tiles. So we're going to use algebra tiles to try to add together some polynomials. Notice that this is two binomials. So this is a binomial. And this thing's a binomial. We're going to represent the first binomial using our algebra tiles. So we have, we don't have any x squares. We have 2 x's. So 2 long skinny ones. They're shaded in because they're both positive. And then we have plus 3. So 3 little individual guys all colored in. The second binomial, we have minus x, so a long skinny guy, not shaded in, and then we have plus 5. and we want to add. So we want to add the group on the left with the group on the right. So when you're adding, it's quite simple. You're going to look at your long sticks first, and you're going to see that any positive ones over here get canceled out by any negative ones over here, so we lose 1. And we're left with 1x over there. So one long skinny one. Now, we look at our little individual tiles, and again, any ones on the left would be canceled out by any non-shaded ones on the right. But in this case, there are no non-shaded ones on the right. They're just all shaded. So we just count it up. We have 1, 2, 3, 4, 5, 6, 7, 8 of those guys. So we need 8 of them. And we shade them all in because they're positive. These algebra tiles are really just a good representative of what we're doing. So they get to actually show that we had 2 x's, we minus 1x, we had 3 singles, and we added 5 singles. Now we can also do this kind of addition and subtraction of polynomials without algebra tiles. In fact, it's probably a little easier without algebra tiles because then there's less writing to do. But before we can do any real addition or subtraction, we have to remember something, and it's called collecting like terms. So collecting like terms, my saying is always letters go with letters and numbers go with numbers. So if you look at this very first example, I'm going to look for all the letters that are the same. So we have some z's here, some z's here, and some more z's there. Notice they're all the same letter with all the same exponents. They're all exponent 1. So if you have all the same letters with all the same exponents, you can just add their coefficients. So their coefficients are the numbers in front of them. So if we have 4z minus 8z and plus 12z, we can think of that as 4 minus 8 puts me down to negative 4z's, and then plus 12z will bring me up to positive 8z. So all these like terms combine together to be 8z. I then look at all my numbers. So we've got 2 minus 3 plus 10. Those can all be added together, and that will give you plus 9. That's called collecting like terms. That shouldn't be too new to you. Just a little bit of reminder from previous years. All right, B. Notice we have a binomial minus a binomial. And this minus sign, being outside of the brackets, means we have to do something fancy to the brackets to the right of it. We don't like negatives that are outside the brackets. So what we do is we change it to a positive, and anything to the right of that sign now has to change to the opposite sign. So that first negative becomes a positive, and that other positive becomes a negative. Once we do that, we can now just get rid of the brackets and write it all out. So notice the brackets are now gone because I changed the symbols. I used up that negative sign. It means I used up those brackets. Again, we can collect our like terms. So x's go with x's to give us 6x. And then numbers go with numbers to give us minus 3. It's also important to note that we are writing our answers from variables go first. So the variables go first. And then the constant, the thing with no letters attached to it, goes last. Okay, so for C, we're going to practice that again. Remember this little negative symbol? We want to use it up because it's just outside the brackets. So we need to make it a positive. And then we need to go make the 2x a negative and the 9 a positive. So we now have minus 4x plus 7 minus 2x plus 9. So once we change that symbol, we can get rid of all the brackets. And then we collect like terms. So minus 4x minus 2x gives me minus 6x. And then plus 7 plus 9 gives me plus 16. I write it with the letters going first, and then my constant goes last. All right, last one here. Determine the perimeter of the following square. So perimeter, remember, means you want to add all the sides. So perimeter means add all sides. And if we look at our little diagram, they've shown us that one of the sides is 3x minus 14. So if one side is equal to 3x minus 14, that means all the sides are 3x minus 14. And that's what these little lines here mean. These lines mean all these sides are equal. Anywhere where you see a line going through means they're equal. So if we want to find the perimeter, we need to add all the sides. So the first side is 3x minus 14, the first side. Now plus the next side, another 3x minus 14, plus the next side, so 3x minus 14, and then plus the last side, which is 3x minus 14. Our like terms are going to combine, so letters go with letters. So 3x plus 3x plus 3x plus 3x would give us 12 x's. And then all of our minus 14s are going to go together because they don't have any letters with them. So minus 14, minus 14, minus 14. That will give us minus 56. So the perimeter is 12x minus 56. And that's our final answer. You can now finish the first portion of your practice booklet, and that's what you should be doing so that you come to next lesson, 2.2, with good skills of combining like terms and defining polynomials.